Let's start with Chapter 7. Chapter 7, we will look into continuous random variables and continuous random distribution. We start with what is a continuous random variable. A continuous random variable are outcomes that take on any numerical value in an interval, including numbers with decimal points. The probability that a continuous random variable equals a specific value is always equal to 0. It is equal to 0 because basically the probability of x to be equal to a specific value will be 1 over infinity, which is really, really close to 0. Normal distribution. The normal distribution is one of the most popular, the most commonly used continuous probability distributions. It has the following characteristics. These characteristics, you need to know them very, very well. The distribution is bell-shaped and symmetrical about the mean. Because of the shape of the distribution is symmetrical, the mean, the median are the same value or approximately the same value. Random variables around the mean where the curve is the tallest have a higher likelihood of occurring than values towards the end of the distribution where the curve is lower. What you need to always remember is that the total area under the normal curve is always equal to 1. Because of the distribution is symmetrical around the mean, the area to the left of the mean equals 0.5, and so does the area to the right of the mean. The probability is always positive. Just because the area is to the left of the mean, that does not mean that you're going to have a negative probability. You're going to have a negative z-score, but the probability is always positive. The left and the right ends of the distribution extend indefinitely, never quite touching the horizontal axis. A smaller standard deviation results in a skinnier curve that's tighter and taller around the mean. A larger standard deviation makes for a fatter curve that's more spread out and not as tall. The formula for the normal distribution density function is the following. You have the information. To find the area of the bell curve, we can use calculus or check the values in the chart. The chart that we will be using for the normal distribution, you can find it under my MATLAB menu. You're going to go to charts, and you will print out the z-chart, which is for normal distribution. Always have this chart printed out so you can have easy access on the information. So the chart is this one, the standard normal distribution table. What I want you to understand when you look at the table, I want you to be able to understand what this table gives you and how to read the table. So in all cases, regardless of the areas that you are looking for, this table will give you the area from 0 to the z-score that you have calculated. So the area to the right if you have a positive z-score, or the corresponding area to the left if you have a negative z-score. So once again, regardless of the area that you will be looking for, this table, the one that I will be using, always gives you the area from the mean to the z-value. So this is for standard normal distribution. That means when you have standard normal distribution, you have mu equal to 0 and sigma equal to 1, which means that you calculate the z-score. So based on the z-score, we always round up to 2 decimals because our distribution table uses 2 decimals. So let's say you had calculated the z-score and the z-score was 1.23. So you would go to your table. 1.2 is right here. And you would move across to find 0.3, which is right here. Where do these two meet? This will be the probability 0.3907, which means this would be this area. So this area would be 0.3907. So this is how you read your table. If you ever end up with a z-score that's more than 3.59, you can automatically assume a probability of 0.4999. The normal distribution z-score determines the number of standard deviations that a particular value x is from the mean. In general, z-scores follow a normal distribution with mu equal to 0 and sigma equal to 1, as we just mentioned. The z-score is calculated by using the formula x minus mu over sigma. X will be the value that you're calculating the z-score for. Mu will be your population mean. Sigma will be your population standard deviation. The z-score for a normal distribution are negative for values of x that are less than the distribution mean, are positive for values of x that are more than the distribution mean, and are 0 at the mean of the distribution. Now, when we calculate probabilities based on the z-scores, the first step is to read the probability of the z-score in the chart, as I showed you before. Use the row for the first decimal unit and the column for the second decimal unit. So, let's look, for example, case 1. We want to calculate the probability when the z-score is between 0 and a positive number. So 0 and a positive number, or z-score is between 0 and a negative number. In this case, we check the table of the normal distribution, and the probability, the area, will be given directly from the chart. So if you're looking for an area between 0 and a specific value, positive or negative, whatever probability you get from the table, this will be your answer. For example, I want to find the probability where the z-score is between 0 and 1.77. Since you're looking for the probability of z, that means you already have standard normal probability distribution. Standard normal probability distribution has a mu equal to 0. This is your z-score. So this is 1.77 is to the right because it's positive. And I'm looking for the area between 0 and 1.77. So I'm looking for this area. We go to our table and we look for the corresponding probability for 1.77. So you will go 1.7 right here. And 0.7 here. Where do they meet? 0.4616 for the probability. So this is the area that your table gives you, and this also happens to be the area that you are looking for, so there's no need to make any adjustments. This is the answer to the question. Another example. I'm looking for the probability where the z-score is between negative 2.15 and negative 2.15 and 0. So negative 2.15 is to the left of the mean since it's negative. I'm looking for this area between 0 and negative 2.15. You will take the absolute value of the z-score, 2.15, that is, 2.1, and then you will move across to 0.5, 0.4842, 0.4842. So 0.4842 is the area you're looking for, and therefore also the answer to the question. Once again, keep in mind that you might have a negative z-score like you have here, but the probability is always positive, always positive. Now, case number 2. Calculate the probability when the z-score is greater than a positive number or less than a negative number. This is going to be a right tail or a left tail area. In this case, we check the table for the normal distribution for z-score, and the probability will be given from the chart, and then subtract the probability from 0.5. So basically, anytime you are looking for a tail, either a right tail or a left tail, you will check the probability for your z-score from your table. This probability will be this area, and since you're looking for this area, you will subtract from 0.5 the probability you have found from your table. Why do we subtract from 0.5? because based on the main properties of the normal distribution, the total area is 1. The normal curve is symmetric about the mean. That means that the mean separates the two into 0.5 and 0.5. If this is 0.5 and I subtract the area that I get from the table, I will be left with the area that I want. Let's look at this example. Calculate the probability where the z-score is greater than 1.85. 1.85 is to the right. Greater than 1.85, I'm looking for the area to the right. I check the table for 1.85. This will give me a probability of 0.4678. This is not the answer. This is not what you're looking for. To find the area you're looking for, you will need to subtract from 0.5 this probability, and your answer will be 0.0322. On the other side, another example, let's say we wanted to find the probability where the z-score is less than negative 0.75. Negative 0.75 is to the left of the mean since it's negative. Less than negative 0.75, I'm looking for the area to the left of negative 0.75. Therefore, I'm looking for a left tail. When I check the table for 0.75, so once again, just to remind you, 0.75, you have 0.7 here, and you move across to find 0.5. It's 0.2734, the corresponding probability. 0.2734, however, again, is not the answer. It's this area. I'm looking for this area from the mean to the z-score. I'm looking for the area that's less than the z-score. Therefore, we take the half, 0.5, we subtract the area from the table, and the answer, the area, will be 0.2266. Now, we want to calculate another case, the probability when the z-score is between a negative number and a positive number, a negative z-score and a positive z-score. In this case, we check the table of the normal distribution for the probability for z1, we check the table for the probability of z2, and then we add the corresponding probabilities. So you check basically for this area, and then you check for this area, and then you add the corresponding probabilities. So let's say we wanted to find the probability where the z-score is between negative 2.5 and 1.5. So you go to your table, you take the absolute value for negative 2.5, which is 2.5, you check your probability. This will give you a probability of 0.4938. Then you go to the z-table again, you check for the corresponding probability for a z-score of 1.5. This will be 0.4332, and based on the area you want, you simply add the two probabilities. So the answer for this question will be 0.9270. Just a note to that, when you don't have, for example, z-scores and you have regular numbers, always remember that if you're looking for an area where the mean is inside the area you're looking for, you will always be adding at the end the corresponding probabilities. For the next case, calculate the probability when the z-score is between two negative numbers, two negative z-scores, or two positive numbers, two positive z-scores. In this case, we check the table for the normal distribution for the probability for z1. We repeat the same steps for z2, and then we subtract the smallest probability from the largest. So, when you're looking for an area between two positive z-scores or two negative z-scores, you check your table for z1, for example. Your table will give you this area, and then you check your table for z2, you will get this area. So you subtract the smallest area from the largest, and you will end up with the area you're looking for. Same thing with the two negative z-scores. So let's look at this example. we are looking for the probability where the z-score is between negative 2.7 and a negative 1.65. If you check the table for we take the absolute value 1.65, you're going to have 0.4505. So this area here will be 0.4505. And then if you check your table for 2.75, this area here will be 0.4970. So all I need to do is take this area and subtract from this area this part, which is 0.4505. So the probability that I'm looking for will be 0.0464. Also, notice here, when you're looking for an area between two values where the mean is outside the area, always remember that you will be subtracting the two probabilities, and again, using the table that I have given you. There are multiple tables you can use for normal distribution. However, based on the table that we will be using, these are the steps that you will have to follow. Now, the following table is a summary of the 4 cases. This is really, really good to have whenever you do the problems. A very quick reference. And let's now look at the steps when we have a normal distribution and we want to turn it into a standard normal distribution in order to be able to use the table that we have for the probabilities. So the first step we need to do is we identify the mean, the standard deviation, and the probability that we are looking for. We graph the normal curve. And we shade the area that we are looking for. We always include the mean. This will give us a point of reference. And then the next step is to calculate the z-score for whatever value we have, x minus mu over sigma. Once you have the z-score, you are basically turning the normal distribution into a standard normal distribution with mu equal to 0 and the corresponding z-score. And you're looking for this area. And we have to go through that. So this is the normal distribution, this is the standard normal distribution, and we use the z-score to turn the normal distribution into a standard normal distribution. Once we have the z-score, we check our table, and in this case, if I'm looking for a tail, I subtract from 0.5 whatever probability I got, or in any other different case that we have covered. Let's look at the examples. These are typical examples of what you should expect for the normal distribution. A company that sells annuities must base the annual payout of the probability distribution of the length of life of the participants in the plan. Suppose the probability distribution of the lifetimes of the participants is approximately a normal distribution with a mean of 68 years and a standard deviation of 4 years. The proportion of the plan recipients would receive payments beyond age 75. So we have new 68, and we have sigma equal to 4. I'm looking for the probability of x to be greater than 75. Pay attention because we don't have z-score here, we have the x value. We have the normal distribution that we need to turn into a standard normal distribution. So we draw the normal curve. Mu is 68. 75 is to the right because it's greater than the mean. I'm looking for the probability of x to be greater than 75. Therefore, I'm looking for a right tail. Next step, we calculate the z-score. 75 minus 68 over 4. Your z-score will be 1.75. Once you have the z-score, you go to your table. You go to the table and you look for the corresponding probability for 1.75. Let me show you one more time. 1.7, and we move across to 0.5. 0.4599 for the corresponding probability. So this area here is 0.4599. This is not the area you're looking for a tail. So this part is 0.5. We subtract 0.4599 from 0.5, so the probability that I'm looking for will be 0.0401. The next example, we know that the length of time it takes a college student to find a parking spot, it follows the normal distribution with a mean of 3.5 minutes, sigma equal to 1. Find the probability that a randomly selected college student will take between 2 to 4.5 minutes to find a parking spot. So, this is the probability I'm looking for. Nu is 3.5. 2 is to the left, less than the mean. 4.5 is to the right, greater than the mean. I'm looking for the area between two values where the mean is inside the area. If you remember from the cases, when we have an area between two values and the mean is inside the area, at the end we will be adding the probabilities. So, next step, I have to find the z-score for 2 and I have to find the z-score for 4.5. The z-score for 2 is a negative 1.5. We expect it to be negative because it's to the left of the mean. And the z-score for 4.5 is 1. We find the corresponding probabilities from the table and then we add them. So the probability of that occurring will be 0.7745. Now, onto a different continuous probability distribution, the uniform distribution, or otherwise called the rectangular distribution. It is a simple type of continuous probability distribution. Since it continues, it has a graph, and the area of the graph is the probability, excuse me. The graph for uniform probability is rectangular. With a continuous uniform distribution, the probability of any interval in the distribution is equal to any other interval with the same width. The formula for the uniform cumulative distribution is the following. So if you're looking for an area between two values, the probability where x will be between two values, you subtract the largest value from the smallest over the end point minus the beginning point of the uniform distribution. The mean, the variance, and the standard deviation of the continuous uniform distribution are as follows. The mu is a plus b over 2. Once again, a is the starting point, b is the ending point, and you divide it by 2. The variance is b minus a squared divided by 12. This is the number used, and therefore for the standard deviation we take the square root of that, which will be b minus a over the square root of 12. So let's look at an example. And whenever you have a uniform distribution, it will always be stated. Suppose the time interval between two consecutive defective light bulbs from a production line has a uniform distribution over an interval from 0 to 90. So 0 is your A, 90 is your B. What is the mean, the variance, and the standard deviation of the time interval? We just mentioned that the mean is A plus B divided by 2, 0 plus 90 divided by 245. The variance, 90 minus 0 squared over 12, 675. And the standard deviation, we take the square root of that, 25.981. The standard deviation, once again, is always the square root of the variance. Let's look at this example. What is the probability that the time interval between two consecutive defective light bulbs will be less than 10 minutes? This is a uniform distribution with alpha 0, b, beta 90. We want to calculate the probability where x is less than 10. 10, let's say, is here. Less than 10, I'm looking for basically the area between 0 and 10. So we will do 10 minus 0 over 90 minus 0. So that's going to be 0.111. What is the probability that the time interval between two consecutive defective light bulbs will be between 10 and 35? So now I'm looking for the area between 10 and 35. The probability will be 35 minus 10 over 90 minus 0, which in this case is 0.2778. So this concludes the notes for Chapter 7.